Recent observations have startled astronomers, suggesting that we have vastly underestimated the size of Betelgeuse and its timeline for evolution. Incredibly, this means that the mighty star is poised to explode within a few tens of years, rather than the previously thought hundreds of thousands. Situated approximately 650 light-years away, Betelgeuse's radiance today reflects its state 650 years ago. If the study holds, we could be on the brink of witnessing a rare cosmic spectacle, the supernova of Betelgeuse, in our lifetime. Curiosity peaks as we delve into the methods employed by scientists to arrive at this groundbreaking conclusion. What evidence supports their bold hypothesis? And perhaps most tantalizingly, what awaits us if the light from Betelgeuse's supernova reaches us while we still roam the Earth? Join us on this enthralling exploration of cosmic wonders as we unravel the mysteries surrounding Betelgeuse and the breathtaking possibilities that lie ahead. Don't forget to like and subscribe to our channel to stay tuned for more captivating astronomical revelations and space explorations. Together, let's embark on this extraordinary journey through the cosmos. Betelgeuse, resting on the shoulder of Orion, is about 200 parsecs away from us, which roughly translates to 650 light-years. It's quite the distant neighbour, wouldn't you agree? Now, hold on tight as we unravel the recent revelations about Betelgeuse's size and evolution timeline. Astronomers have discovered that we were wrong all along, thanks to their in-depth study of its pulsations. But what exactly are pulsations? Well, let me break it down for you in a simple way. Stars are more than just those static points of light in the sky. They have a rhythm of their own. Think of it like a stellar heartbeat. Stars pulsate because they constantly expand and contract, just like how your heart expands to fill with blood and contracts to pump it throughout your body. Now, this pulsation is a result of a cosmic tug-of-war between gravity trying to crush the star and the resistance from nuclear fusion energy and gas pressure. The fundamental mode of pulsation is the star's simplest way of pulsating, just like a basic heartbeat. The entire star expands and contracts together, much like jumping straight up and down on a trampoline. Imagine yourself jumping in the middle of a trampoline. The whole surface goes down and comes back up in unison. That's similar to the fundamental mode of a star's pulsation. But wait, there is more. Stars also have overtones, which are more complex modes of pulsation. Unlike the fundamental mode, overtones involve different parts of the star expanding and contracting at different times. It's like having multiple people bouncing on a trampoline in different spots. With each person bouncing at their own pace, the surface of the trampoline won't move uniformly. Instead, it creates a complex pattern of waves. Similarly, the overtones in a star's pulsation involve different parts of the star expanding or contracting independently of each other. Now, here comes the exciting part. By studying the periods of these pulsations, astronomers can unravel the conditions inside the star that give rise to these captivating pulsations. It's like deciphering the secret language of the stars. So, you know how they say you can understand a person's soul by their actions? Well, astronomers are like cosmic detectives, and they've been doing just that with Betelgeuse. Over the centuries, they've closely observed its behavior on the outside, and boy oh boy, did they stumble upon something truly remarkable. Betelgeuse has been known to put on a spectacular light show, with its semi-regular variations captivating astronomers' hearts. They discovered not one, not two, but 4 pulsation cycles. A 2,200-day cycle, a 420-day cycle, a 230-day cycle, and a 185-day cycle. Quite the rhythm, right? Now, the cosmic brainiacs initially believed the 420-day pulsation cycle was the star's main act, the fundamental mode, if you will. The shorter cycles were merely its overtones, like the star was singing its cosmic tunes. But hold on tight, because there's a twist in this stellar tale. In a groundbreaking research paper, our cosmic detectives, led by Seo and their brilliant colleagues, dropped a bombshell. The 2,200-day cycle is not just any sidekick, it's the star's true rock star, the fundamental mode. And those shorter cycles, well, they're just the funky beats that accompany the star's grand performance. What does all of this mean, you ask? Buckle up, space enthusiasts, because this revelation has us starstruck. Betelgeuse is no ordinary star. It's a cosmic giant. It spans over a whopping 1,200 times the size of our beloved Sun, a size so massive that it stretches beyond the orbit of mighty Jupiter. So, did you know that stars, like Betelgeuse, spend about 90% of their lives converting hydrogen into helium in their fiery cores? This phase is aptly named the main sequence phase. For a star the size of Betelgeuse, it can last an astonishing 10 to 12 million years, with temperatures soaring to a blistering 15 million Kelvin. But, like all good things, this phase eventually comes to an end. As Betelgeuse exhausts its hydrogen supply, it enters the red giant phase. Gravity causes the core to contract and heat up, while the other layers expand and cool, giving the star its characteristic reddish hue. Now here's where the plot thickens. When the core temperature reaches a scorching 100 million Kelvin, Betelgeuse starts burning helium, creating heavier elements like carbon and oxygen. Over time, the core turns into an onion-like structure, with the heaviest elements at the center and lighter ones forming shells around it. But here's the twist. When the core temperature becomes high enough, carbon and oxygen fuse into even heavier elements, up to iron. However, iron is a game changer. Unlike other fusion reactions, iron absorbs energy instead of releasing it, destabilizing the core. And that spells doom for our beloved Betelgeuse. It would take roughly 1,000 years for a star of its size to fuse carbon into heavier elements. But as iron accumulates, the core becomes unstable, setting the stage for a spectacular finale. Now, let me tell you, it's no easy feat for scientists to pinpoint the exact amount of carbon left in a star's core. It's like trying to count all the stars in the sky. Challenging, but oh so fascinating. But fear not, we've got some thrilling insights to share. When researchers studied Betelgeuse's pulsations and brightness, they made an electrifying discovery. The core of this blazing star has just a teeny tiny fraction of carbon left. We're talking anywhere from 0.48% to 17%. Betelgeuse has been partying hard and used up a significant chunk of its carbon stash. But wait, what does this all mean? Here's the cosmic scoop. Betelgeuse is on the verge of a stellar explosion. From our perspective, it's like a ticking cosmic time bomb with just a few decades left before going supernova. Crazy, right? In real time, Betelgeuse might have already gone kaboom. But hold on tight, there is more. Recently, it's been acting rather weird, like a star having an interstellar identity crisis. Betelgeuse experienced a great dimming in 2020 and lost its pulsation cycle that had been going strong for centuries. Like an unpredictable cosmic diva, Betelgeuse is keeping scientists on their toes. And here's where it gets even more exciting. The last supernova we saw with our naked eyes in our galaxy was back in 1604, a stellar spectacle for the ages. But now, with the revised timeline for Betelgeuse's explosion, there's hope we might witness this jaw-dropping cosmic show in our lifetime. When Betelgeuse finally unleashes its fierce brilliance, brace yourself for an awe-inspiring sight. Its brightness will surge dramatically, potentially outshining even the moon and making it visible during the day. A celestial spectacle like no other. Now, don't blink, because this magnificent display won't last forever. After a few weeks of radiant grandeur, the light will gradually fade. But don't despair. Betelgeuse could remain visible to the naked eye for an extended period, possibly over a year. Lucky for us, despite the immense energy released during the supernova, the vast distance between Betelgeuse and Earth ensures that we won't suffer any adverse effects from its explosion. Our beautiful blue planet is well shielded from harmful radiation by the vast expanse of space. Supernovae, like Beetlejuices, are rare and precious cosmic events within our galaxy. They provide invaluable insights for scientists to understand the life and death of stars, the intricate physics behind the supernovae, and the dispersal of elements throughout the universe. Think of them as celestial factories, producing elements like gold and platinum. As the dazzling show concludes, Betelgeuse's core will still exist, but it will have transformed. It could become a neutron star, or perhaps even a mysterious black hole. It's fascinating, isn't it? Though spotting the remains of Betelgeuse from Earth might be challenging, advancements in technology have opened new possibilities. Astronomers recently spotted the largest explosion in the universe, an event so energetic that even physics phenomena are struggling to explain it. The universe continues to surprise us. And that's a wrap for today's video on the star about to go supernova. I hope you enjoyed this fascinating discovery as much as we did. Now, we want to hear from you. Share your thoughts and opinions on this cosmic event in the comment section below. And don't forget to hit that like button if you found this video enlightening. Stay tuned for more mind-blowing content coming your way. Thanks for watching, and until next time, keep exploring the wonders of the universe.